In the previous session, we get the Z value as 2.5298. That was my Z, and therefore mod of Z is definitely the same thing, 2.5298, because it is a positive quantity, which is of course less than 3. So we need to find out a suitable level of significance at which it would be tested. Now listen to me very carefully. I can see only 11 participants are there now. In the previous session, more participants were there, but this drawing of conclusion was the important thing that I actually wanted all of you to be all of you to listen to it properly. But some students are always there for putting their attendance. So, anyways, if they ask you something, you will just explain them to, and you will be learning it. If someone learns, if someone can explain it properly. Okay, forget about it. Mod Z is less than or 3. So here we are going to accept the null hypothesis temporarily. Now here we have to choose a suitable level of significance. Now the suitable level of significance is already mentioned in the problem. They have asked us to test the hypothesis for 1% level of significance. Okay, suppose in the problem no suitable level of significance is given, then we have to consider both 5% level of significance and 1% level of significance. In the previous session, I wrote that level of significance are actually of two kinds. One is called the 1% level of significance, and another is called the 5% level of significance. Now, what is level of significance? That is the important thing. First of all, we have to know what definition of level of significance. Level of significance is a kind of probability. Level of significance is a kind of probability with which or for which H0 is rejected. Okay, this is a kind of probability. Why it is getting rejected? Now just look at the figure. Actually, what type of test we are doing? You are doing a normal test. This is called a jet test that we are doing because we are using the normal standard normal variate formula over and over. Now this is the test. This is the Z value. Z value is 0 at the middle. Now 5% level of significance is just the thing which is opposite to, it is what? It is opposite to the word the confidence level. Okay, 5%. Suppose this is a figure. This is the point that I am going to make over here. This is a point at equal distance from Z equal to 0. Now, if this portion, if it is a two-tail test, then the normal curve will be having two tail, isn't it? And the sum of the two tails, suppose let us call it as T1 and let us call this part portion as T2. The sum of the two tails is actually equal to T1 plus T2. This probability is actually equal to 0.05. Or we'll say that this together, I mean, total of this portion, T1 and T2 will contain 5% of the data. Listen to me very carefully. I have drawn a normal curve. And in this normal curve, since the test is two-tailed, so we know that this normal curve will be symmetric, and it will be symmetric about Z equal to 0 line. Now the two sides are open. Z equal to 0 is the middle point. We have considered a point for which, suppose this point is Z1 and this point is Z. This is minus Z1 and this is plus Z1. Situated at equal distance from z equal to 0 on both sides. Okay. Now outside this point, this particular point, the shaded region below minus z1 is marked t1, and the shaded region below above z1 is marked t2. Now t1 plus t2 is the combined region. Now when we talk about the level of significance, and we say that level of significance is 0.05, it means the shaded region, combined of this shaded region, will contain 5% of the data. So this region, as I wrote in the previous class, this region is called the critical region. This region is called the critical region, and this region is also called the critical region, if you can recall. So combined of these two critical region is 0.05, and it means that total of this region will contain 5% of the data. And since the total of this is 0.05, since total of this is 0.05, so this portion only will contain 0.025 proportion of data, and this portion will contain 0.025 proportion of data, so that the total is 0.05. Okay. And in between the proportions, this part, let me mark it properly. This portion of the curve, this is called the acceptance region, as you know. This is called the acceptance region. Let me mark it first of all. Let me write it over here. It is called acceptance region. Now, if the rejection region's probability is level of significance, which is denoted by alpha, the acceptance region always gives you the confidence interval. How much confident you are that your data is going to fall inside the acceptance region. So if 0.05 level of significance is equivalent to 95% confidence limit, they are one is contrast to another. 0.05 level of significance is in contrast with 95% confidence interval. I think I have to write it over here properly. It is not 0.05% or 0.05 level of significance is in contrast with 95% confidence limit. Just like black and white. 0.05 is, if 0.05 to you is black, 95% confidence limit is white, like this. So they are in contrast with one another. So once I see that in my test statistic, okay, the formula, many things that I actually need to discuss over here, I sometimes forget. The formula over here, that is the formula that I have used. Any formula is in hypothesis testing is actually called test statistic. I hope you are noting down everything properly. Any formula in hypothesis testing is called test statistic. What is statistic? Statistic means sample observation. Any sample measurement, that is called statistic. And we are testing the sample measurements. Therefore, any formula is called test statistic. So in this particular problem, we discussed the test, we have found the test statistic to be having this value, and it is less than 3. And we are supposed to consider the 1% level. We are supposed to consider the null hypothesis at 1% level of significance. Okay. Although it is mentioned in the problem that you find the significance of the hypothesis at 1% level of significance, I am, for this particular problem, I'm going to do it for both 5% level of significance as well as for 1% level of significance, just to show you that both can be done. Okay, I'll not be specific over here according to, as per the requirement of the problem. Now the conclusion, step number C. If we consider 5% level of significance, if we consider 5% level of significance, then how to draw the conclusion? This is the part, isn't it? If your modulus Z is less than or equal to 1.96, then H0 is accepted at 5% level. If your mod Z is greater than 1.96, then your H0 is rejected at 5% level. This is the first part. Step number C, it is A. Step number C, B. If we consider 1% level of significance, then if mod Z is less than or equal to 2.58, then H0 is accepted at 1% level. If mod Z is greater than 2.58, then H0 is rejected at 1% level. What does this mean in figure? If I draw the figure, this is the normal curve. This is the point minus 1.96. This is the point plus 1.96. This is the middle. This is the median, Z equal to 0. Okay, and this is region T1. This is region T2. Here T1 plus T2 is equal to 0.05. Okay, and the acceptance region is 95%. It is the confidence interval. Acceptance region is 95%. Now, if you find mod Z less than or equal to 1.96, if you find the probability of this thing, by the way we find probability in normal distribution, it will break the modulus sign. It will take this particular shape, and we will find the probability to be, from the normal chart, this probability will be 0.95. From the normal chart, this probability will be 0.95. You can check it now or you can check it later. Okay, so this probability is actually giving you 95% confidence interval, and consequently the 5% level of significance is coming. That means if the data is falling between minus 1.96 to plus 1.96, if its probability is 95%, its proportion probability is 0.95, the data will not fall in this particular region. This probability will be 0.05. So it will not fall in this region, means either it may fall in the region T1 or it may fall in the region T2. That we don't know because it is a two-tailed test. We never know it for now. Okay, and If I'm talking about the 1% level of significance case, so we are again going to draw the normal curve. My curve drawing is not good. We are again going to draw the normal curve or mesocartic curve. Here z equal to 0. The point would be, in this case, would be minus 2.58, and this would be plus 2.58. Okay, and 1% level of significance, that means we are talking about this region. This is my region T1 prime. This is my region T2 prime. T1 prime plus T2 prime. This is actually 0.01. And the confidence interval, that means whether the data is falling inside the region from minus 2.58 to plus 2.58. This will give you 99%. This chance is 99%. So this is 99% confidence interval. You are 99% sure that your data is going to fall inside this particular region. Now, again, if you try to break the probability, if you try to find out the probability of this quantity, okay, by the technique of the normal curve, technique of using the normal curve, just we did in the chapter of normal distribution. From the normal chart, you will find that this value is going to come out as 0.99. So the confidence interval is actually that probability that the data is going to fall inside the region in this acceptance region, but it will not fall in the acceptance region. That would be I mean that would be giving you the probability of the, which is known as the level of significance. Okay, now a very interesting thing is going to happen with respect to our problem. So let us first draw conclusion for our given problem, and you will find it why it is so important. Now, conclusion, the final conclusion that we are going to make over here. If we are going to test for 1% level of significance, 5% level of significance testing, they have not asked for 5% level of significance testing. They have asked for only 1% level of significance testing. We are going to do both testing. We are going to do both of the testing for the sake of better understanding of the situation. Okay. Now, according to the rule, mod z has come out to be 2.5298. And if I consider the 5% level of significance, you see that this is greater than 1.96. Okay. So according to the rule, your H0 is going to be rejected, and you would say going to be rejected at 5% level, at 5% level, and you would say rice and wheat are not equally popular. Rice and wheat are not equally popular. Okay. And same situation, if I consider the 1% level of significance, you see that this 2.5298 is less than 2.58, and therefore H0 is going to be accepted at 1% level of significance, and you would say rice and wheat are equally popular in the state of Maharashtra. Two conclusions of the same problem. Now, every problem has, you know that in every mathematical problem needs to have a single solution, okay, unique solution. But here we are going to get a situation where two different types of solutions are coming. This is a very interesting part, and probably you are also, I mean, thinking about it in your mind. How can this be? So at one point, we are saying that rice and wheat are not equally popular. And then at another point, we are saying that rice and wheat are equally popular. Now, how can this be? The thing is that this particular type of thing that we have done over here, this level of significance kind of thing or whatever, these are all, I mean, statistics. Sometimes I say the statistics is a subject of manipulation. Now, you have collected a data. Let's start from the beginning. You have collected a data. On the basis of the data, you have considered a satisfactory statistical tool, and in that tool, what you are you have applied it correctly, no problem. Up to this is no problem. Then when it's a matter of considering the conclusion about the situation, you have selected two levels of significance. In one level of significance, you are observing that your hypothesis is going to be rejected. In another level of significance, you are seeing that your hypothesis is going to be accepted. First of all, you have to understand when we say that mod z is less than or equal to 1.96, or whenever we say that H0 is accepted at 5% level of significance, what do we mean by that? It means that when we are going to select a sample, a large sample from the population, and if we are going to repeat the experiment, if we are going to count the rice eating people and wheat eating people, just like we did in the previous case. Now, suppose for the next time, we are going to see for 10,000 people, not 1,000 only. Then also there will be a probability, 5% probability that your data will not be inside the acceptance region. 5% error will always occur in the observation for some reason or other. Okay, that reason, the reason for that particular occurring of this kind of situation is not known. Why this should occur? Why there is always 5% chance that your data is going to fall in the critical region? There may be many possibilities, many reasons for this, but it is going to happen always. If you repeat the experiment, there is a 5% chance that your data is going to fall in the critical region. And if you are dealing with 1% level of significance, that means there is always a chance your data will be fall in the critical region, 99% critical region. So this is the thing that is going to happen if you keep on repeating the experiment again and again. This is the situation. Now you see, if you consider the horizontal scale to be a scale, and this where you can slide the bars, okay, to expand it or to contract it. Now whenever I'm if I try to draw 2.58 over here somewhere, okay, let's draw the two figures together. Say for example, this is my normal curve, and this is my z equal to 0. Suppose this point is minus 1.96, and this point is minus 2.58. This point is 1.96, and this point is plus 2.58. What is happening is that if you increase the acceptance region, your data of this rice and wheat eating people are going to fall in the acceptance region. Actually, your data value is actually falling here in this particular case. 2.52. This is actually falling here or here. Okay, means since this is a positive quantity, so it could have been negative also. It is not like that the Z is always negative. So in this particular special case, it is falling here. In this particular case, it is a positive one. So this is my data value, and it is falling between 1.96 and 2.58. But if you contract the region from minus 1.96 to plus 1.96, with respect to that perspective, your data is falling outside the critical region. Now, if you want to politicize the statistics is a science. We do it in a well manner. But if you want to try to politicize the statistics, then you can take the help of this situation. If you want to show that the rice eating people and wheat eating people are equally popular in Maharashtra, then you will increase your confidence interval and show it that it is equally popular. Politicians do it. And if you want to show, politicians don't do it, they put the objective, statisticians do it. And if you want to show that it is not equally popular, contract your scale and show that it is not equally popular. So that's why when a data came with respect to anything, say for example, nowadays we always look for the data of COVID-19 patients, and now Omicron patients, or like this data is actually, and sometimes you see in the news channel, the data is falsified. Last week, I saw in one of the news channels, it is said that Pfizer data is not reliable data. Okay, that is a falsified data. Now, if it is so, now this can be, I do not have any personal grudge against any particular company or any particular medicine or any particular politician. I do not have any. I'm not going to. I'm just teaching you. I'm just showing you what happens. I don't want to discuss why this happens. I mean, why this objective? Why is it really falsified or not? If suppose I want to falsify the data, or I want to, according to my objective, I want to put forward my conclusion, I can manipulate the scale. I can manipulate the horizontal scale, or like this kind of sliding bar. So when this type of statistical news come, then I don't believe actually. I always look for the data, how many data they have worked on. A few years ago, once in a newspaper I saw that it is written, it has been found from a survey that drinking tea is good for health. Okay, and later in the survey, it is after 2 to 3 weeks, in the same newspaper, in the same editorial, it has been, the big article came where it is written that it has been observed that coffee is far better than tea. Now, suppose you just think, imagine what to believe, whether you are going to believe the first editorial that came 2 weeks ago, or you are going to believe the next editorial which came 2 weeks after. So if I say that, okay, 5% of my 50% of my 100% of my students are actually very sincere. This is a kind of vague information. Suppose I have only one student in my class, so 100% mean only one student is actually very sincere. That is not what is the base, what is the denominator, that is very important. This denominator is very important, which is not mentioned in any newspaper, in any news. They only mention the percentage. Percentage is a kind of scale with respect to 100. But I don't want to know the 100 scale. I want to know how many data, what is the number of data on which you have worked. That is important for me. And that is not mentioned in any news channel, in any newspaper. So until and unless, so you may ask me one question. So what do you actually want to say? Until unless you do statistics by yourself, you are not good. Do not believe anything which is shown to you. If you are doing the statistics by yourself, try to believe it. Try to be ethical. Try to follow all the statistical rules. But until unless you do it by yourself, do not believe blindly any information. Always ask question. Okay. So this much I'm going to discuss for today. I have to go to college also, and therefore I'm stopping here right now. In the next session, we are again going to continue with hypothesis testing with some other situations. Okay, the situation that I discussed is situation of test of significance of single proportion. Next time I'm going to discuss about situation of like a test of significance of difference of two population proportions. Okay, and many more things are yet to come. So see you next week on next Wednesday. Today is Friday, no? Okay, next Wednesday. Till then, bye. I hope you have understood, and just tell your friends that seeing my videos in the YouTube will not work on me. Many videos better than me are available in YouTube. I upload the videos so that if you miss something, some points, later you can revisit them. It is not that for the YouTube videos, you are not supposed to present in the class. You are only present in the class for the attendance. Just say that, communicate this message to the students. Okay, those who are absent today. Thank you so much.